In this problem, you see uh, platform scale consists of a combination of the third and first class levers so that the load on one lever becomes the effort that moves the next lever. And you see in this problem, we have to find the required mass M of the counterweight S that is required to balance a 90 kg load at point L. And you see, in this problem, we are using the weight that is acting at point L and point S. So we have a few members of the truss. And if we take the members A, B, and BG, so you see at point A or pin A, we have a couple of forces. So we can apply movement at point A. And if we take a look at the free body diagram, so we have force in member PG, and we have a horizontal perpendicular distance of 500 millimeters. And you see that the force is moving in the anti-clockwise direction, so it is positive. While the load that is acting at point, and we have the weight, and we have a perpendicular distance of 150 millimeters. And you see, this load is acting in the clockwise direction, so it is negative. So we get the force in member PG, which is 264.87 newtons. And if we take the members GB, member ED, and member HF, so we can apply movement at point F. So you see, we have the force in member ED and a perpendicular distance of 250 millimeters, and it is moving in anti-clockwise direction. And we have the force in member PG, which is about 264.87 newtons. And we have a particular distance of 150 millimeters. And it is negative because it is moving in clockwise direction. So now we got a force in the member ED, which is 158.922 newtons. So our goal is to find the weight at the counter S. So now we have the force in the member ED. So now we can find the mass that is acting at the counter weight S. You see, we have force in member ED of about 158.922 newtons, and we have perpendicular distance of 100 millimeters, while the weight that is acting at point S, uh, you can say ms multiplied 9.81, and we have a horizontal perpendicular distance of 950 millimeters, and it is negative because it is also moving in the clockwise direction. Because you see, we take in this problem that our movement is positive in the anti-clockwise direction. So we get ms. You can see this is the mass of the counterweight as which is 1.71 kilogram.